Hello everyone and welcome to Infotainment Lounge. Today's video is about putting the state symbols. How do we put state symbols on elements and compounds in the chemical equations? There are four main state symbols that are used in chemical equations. One is solid, represented by a small s inside a bracket. Second one is liquid or molten, represented by a small l inside a bracket. Then gas, represented by a small g inside a bracket. And aqueous, represented by a small a, small q inside a bracket. These are the four state symbols which you would commonly see in the chemical equations. Now aqueous means dissolved in water, molten and liquid, they both represent the liquid form of anything. Molten just means the melted form, that the substance is actually a solid at the room temperature, but we heated it to melt, to turn it into a liquid. But both of them are represented as a small l in the equation. Before we move on to how we can select a suitable state symbol for any reactant or a product of a chemical reaction, we need to identify, we need to categorize that component of the chemical reaction into certain classes. By doing that, we can analyze the state of that reactant or the product. So if we have categorized the reactant or the product, then we can look at this series here and sort out its state symbol. If the substance is a metal, you have to put the state symbol solid, because all metals are solids except mercury, which is a liquid. All metals are solid at room temperature. I'm talking about the room temperature and ordinary conditions. For specific reactions in which conditions are very different, these state symbols might not be effective. I am just giving a demonstration of the state symbols under ordinary conditions, room conditions. Okay, so all metals will be solids except mercury, which is a liquid. Acids, they will always be aqueous, because there is no acidity in the absence of water. Then simple covalent, if the molecule is simple covalent, most of them are gases except bromine and water, which are liquids, and phosphorus, sulfur and iodine, which are solids at room temperature and pressure. But this is only for inorganic molecules. For organic compounds, we can look at the properties of that specific homologous series and find out the state symbol of that compound. Moving on to giant covalent substances, according to your syllabus, that would only be carbon, silicon or silicon dioxide. These are giant covalent substances, and for these they will always be solid, because under ordinary conditions they are always solids, and in order to melt them we need a very high temperature. And according to O level and A level syllabus, there are no reactions in which those temperatures are involved. For ionic compounds, we have to look into their solubilities. If the compound is soluble in water, we put the state symbol aqueous, and if the compound is insoluble in water, we will write solid. This is actually the standard state of all the ionic compounds is solid, but we use the aqueous form of ionic compounds in the reactions preferably. This is because the rate of reaction is higher when the compound is in its aqueous form. So in most of the cases, not all but most of the cases, ionic compounds which are soluble in water would be labeled as aqueous, and they would be used in the aqueous form for the chemical reactions. Now, in order to put the correct state symbol of these ionic compounds, we also need to know the solubilities of ionic compounds, because we need to learn which ionic compounds are soluble in water and which compounds are insoluble. I am giving you a list for that. This is the list of solubilities of ionic compounds, and you can pause your video now to note down these solubilities or to take a screenshot for your memory. And as you can see, all compounds of group 1 metals are soluble, all ammonium compounds are soluble, all nitrates and nitrites are soluble, all sulfates and sulfides are soluble except with calcium, barium and lead. This means that only calcium sulfate, barium sulfate and lead sulfates, these are insoluble. Similarly, the sulfides of these 3 metals are insoluble, all other sulfates and sulfides are soluble. So you can go through this list, and you in fact need to learn this list, the solubilities of ionic compounds. This is a very useful thing. Now, as I told you earlier, these states would be considered only under ordinary conditions, under room temperature and pressure. But if the conditions are changed, these states might be changed as well. I can give you a few exceptions that you can come across in your O-level or A-level examination. One of them is combustion. In a combustion reaction, the physical state of water is not liquid, it is gas because of the high temperature. Combustion is an exothermic reaction, and temperature rises very, very rapidly in combustion reactions. So water is not in its liquid form in combustion reactions, it is always in gaseous form. Another exception is thermal decomposition. Now, in case of thermal decomposition means breaking down of a compound by heat. Now, if we are providing heat to any substance, any compound, the temperature is obviously high, and at that high temperature, water is again gas. It would not be produced in its liquid form. And also in the reactions of thermal decomposition, ionic compounds would not be taken as aqueous solutions. They would always be taken in their solid forms, because if we start heating them in their aqueous form, instead of the compound being decomposed, the water will start evaporating. So we need to take them in their standard forms, which is solid. In the reactions of metals directly with non-metals, such as reaction of any metal with oxygen or any metal with any halogen in the direct reaction, when there is an absence of water, obviously the ionic compound formed will not be aqueous, so we would have to put the state solid. Thank you very much. I hope this video was helpful. Keep on watching my videos and subscribe to Infotainment Lounge. And if you have any questions about this video, let me know in the comment section, and do suggest me on what topics should I make my next videos. Thank you very much.